All right, so we have vectors. Vector operations, you have to know these, okay? It's not that they're hard, but I consider these kind of quote unquote freebie marks when it comes to vector operations. So first of all, let's just make sure we're all on the same page. A vector in Rn is an ordered group of numbers. So it's going to be a bracket with numbers separated by commas, right? The number of numbers in this bracket tells you what space it's in. So if there's 3 numbers, it's in R3. If there's 2 numbers, R2, 5 numbers, R5, and so on. In this course, it depends on your prof. Some profs will write it with a V with an arrow on top, but for the most part, on the exam and so on, you're going to see a bolded letter. Okay, that's how they represent a vector. And then what can we do with vectors? Well, we can have scalar multiplication, meaning that if you have any number, in this course, a number is called a scalar, and any vector, what you can do is you can take that number and multiply by the vector. And all you're doing is you're taking the number and multiplying by each of the components, each of the elements inside your vector, okay? Some definitions that you have to know in case it shows up on the multiple choice. And if you were with me for the test 1, test 2, you should be familiar with these definitions, but let's just make sure we're on the same page. If they say that 2 vectors are parallel or collinear, that means the exact same thing, okay? Parallel and collinear means the same thing in this course. It just means that they are multiples of one another. Okay, so one vector is 2 times the other one, or -3 times the other one, or 1/2 the other one, okay? If they say 2 vectors are opposite, it means that they are parallel or collinear, okay? Opposite means that they are parallel, but specifically they are negative multiples of one another. So one vector is -2/3 the other vector, or something like that. Okay, so scalar multiplication, not super hard. You just take the number and multiply into each bracket or each number, but you have to know these definitions that come with it. Vector addition subtraction, super straightforward. When you're adding or subtracting 2 vectors, you just add the components together or you subtract the components. That's it. So let's take a look at our first question. Give this a go, give this a try. We're given the vectors u, v, and w. We want to calculate or compute this vector here, okay? So we want to compute 2 times u, which is 1, 2, 3, minus, in brackets, 1/2 v, so that's -2, 0, 4, plus 2 times w, which is 0, -5, -2. I'm going to give you guys about a minute. I want you to compute this one, okay? Give this a go, and we'll take it up in a minute. Okay, I think we should start taking it up. I see a few hands up. We're just past the 1 minute mark. Let's give it a go, shall we? Okay, so it's just like when you're, back in high school calculating things, you have to follow BEDMAS. So meaning the brackets, you group those together, and then multiplication you do after, and then you do addition, subtraction last, right? So we're going to multiply this first vector here. So 2 times this vector is 2, 4, 6. So you take each of the numbers and you multiply by 2. Then we subtract, okay, in brackets, let's deal with this first. 1/2 times this vector, meaning I'm going to multiply each of the numbers by 1/2. Know how to work with your small fractions, like 1/2, 1/3, 1/4, and so on, okay? Just the small ones, they're not going to make you calculate like 1/374 plus something, like they never do that, all right? So 1/2 times something, it's pretty much like you're dividing by 2, right? So you have -1, 0, and 2. Plus, let's multiply this next one. 2 times this vector, we have 0, -10, -4. Now when you see a bracket, you got to deal with the bracket first. So don't do the subtraction yet. Leave the 2, 4, 6 outside. Subtract, or adding these 2 vectors here. -1 plus 0 is -1. 0 plus the -10 is -10. And then 2 plus the -4, that gives you -2. If you're struggling with any of the calculation stuff, let me know, okay? So, let me know in the Q&A or stop, let me know during the break and I can help you out. Or send me an email. All right, now last step, we gotta do the subtraction. 2 minus -1, be careful with your double negatives. Minus -1 is like adding 1, so that becomes 3. 4 minus -10, so again, that's 4 plus 10, so that's 14. And then finally 6 minus -2, so that's like 6 plus 2, so that's an 8. Okay, I just wanna see a show of hands. How many of you guys got this as your answer? Very nice. About a half of you. The remaining half, maybe you didn't have enough time, maybe I didn't give you enough time, or maybe there's some calculation stuff. So if there's any questions or any problems, let me know, okay? I can help you out. All right, and on the exam, you'll have, more time than a minute to do a question, but it's just usually this question right here. I would say that this question alone is too simple to just be on the exam on its own. On the test, you probably saw a question like this, but on the final exam, this might be too easy, okay? But you need to know how to do these calculations for bigger problems. All right, question number 2. I think this was from like I can't remember, summer or winter final exam. So they told us that we have two vectors u and v, and they're asking us find the values of k. So there's this k thing such that these two vectors are opposite. So if they asked you to find the value of k or c, usually what we want to do is have some kind of equation set up, okay? So we want these two vectors to be opposite. What does opposite mean? You need to know your definitions. This means negative scalar multiple, right? So they're negative multiples of one another. So meaning if I take one vector, let's say u, and multiply by a negative number, I'll get to v. So notice that I do have quite a few numbers already given to me. So I can use what you're going to do is to find this k value or what c value such that they're opposites or collinear, something to do with multiples. You're going to take each of the components and divide them. Okay. So we know that 2 over k has to equal negative 4 over 2, which has to equal 6 over negative 3. Because if they have to be some kind of scalar multiples, some multiples of each other, if you divide these numbers, we should get the same number, okay? That's the whole point with opposites or collinear. Take the numbers and divide them. So if you divide these out, you see that negative 4 over 2, negative 4 divided by 2 is negative 2, 6 divided by negative 3 is negative 2. That's good. That means we have the same number here, meaning that to get from one to the other, we have to multiply by negative 2. So from here, we get an equation, 2 over k has to equal negative 2. How do we solve this equation? Well, we don't like fractions, so let's get rid of the fraction, meaning we have to multiply both sides by k. So we see that the k's cancel, 2 equals negative 2k, and finally, solving for k, we need to divide by negative 2. So k has to be negative 1, okay? So if k is negative 1, then yes, these two vectors will be opposites, because they will be a scalar multiple of negative 2, meaning that they are opposites, all right? So know your definitions, and when it comes to opposites, collinear, that kind of stuff, divide each pair of numbers, and you should get the same number every time you divide. So we're trying to find the k value that makes that the same number, okay? If there's any questions about solving equations, let me know. I can help you out with that too. All right, next up, direction or position vector, depending on which prof you have, they might call it different things, but pretty much this one is how do you convert points to vectors? That's what I like to think about this one. So if in the question they give you points, so for example, point A and point B, and they want you to find the vector going from A to B, what we're going to do is we're going to calculate that doing B minus A. We subtract backwards. A lot of students make this mistake on the test, on the final exam, and then they get the negative of the answer that's correct. That's because they don't subtract backwards, okay? So what I mean is, in this example, we want to find the direction vector going from point P to point Q. If you have points and you want to convert them to vectors, we subtract backwards. So the vector PQ is going to be Q minus P. So it's going to be negative 3, 4, 5 minus 1, 2, negative 3. If you did the other way, if you did P minus Q, you'll get the wrong answer. You'll actually get the opposite vector, okay? So we subtract. Negative 3 minus 1 is negative 4. 4 minus 2 is 2. And then 5 minus negative 3, it's like 5 plus 3, 8. Okay? So the vector going from P to Q is negative 4 to 8. If they wanted the vector from Q to P, then you would do P minus Q, and then you'll get the negative of this. So On the final exam, it's not likely that you'll see a question on the multiple choice that just says find the direction vector. But guess what? Later on in chapter 2, you're going to need to know how to find this vector because they're just going to throw questions at you that they expect you to know how to find these vectors. Okay? All right. So we subtract backwards if we want to go from points to vectors. Next up, section 1.2, we have a length or distance formula. Okay? Length, magnitude, or norm all mean the same thing. And if you look at your textbook, there's mention of all three, depending on your prof. Some of them will call them length, magnitude, or norm. But on the exam, on the final exam, you're going to see the word length is the most popular. All right? But they all mean the same thing. So the length of a vector, I don't care if it's R2, R3, I don't care how many numbers are in that bracket. The length, which is represented by these double lines, is the square root of each of the components squared added together. So pretty much you're going to square each number, add them up, and then take the square root. All right. So in this example here, we want to find the length of V, which is in R4, right? Because there's 4 numbers. But it doesn't matter how many numbers there are. The length is just going to be, we square each number, add them up, and then take the square root. Remember, when you square the numbers, they become positive, right? Because any number squared, positive or negative, it's going to be a positive number. So this is going to be the square root of, square each one. So 3 squared, 3 times 3 is 9. 5 times 5 is 25. 0 times 0 is 0. 4 times 4 is 16. So now we get the square root. Okay, 9 plus 25, that's 34. Plus 16, that's a 50. Okay? So you would leave your answer like this. Now, on older past exams, if you get your hands on some really, really old ones, they made students simplify it a little bit more. So I'm just going to quickly prepare you just in case, I don't know who makes the exam this year, decides to do that. 50 technically is 2 times 25, right? The reason why I picked 25 is because 25 is a perfect square. 25 is 5 times 5. So if they somehow simplify this on the exam and you're like, wait, in the answer options, there's no square root of 50. See if you can simplify by breaking this down into 2 numbers multiplied together where one of those numbers is a perfect square. Because now this turns into the square root of 2 times the square root of 25, and square root of 25 is 5. So this is 5 square root of 2. Now, I don't think it's likely they'll make you do this. Like I said, going, in more recent years from like 2015, 16 up to like 2020, they don't make students do this, but on older exams, I've seen it. So just wanted to prepare you. All right. But it's just a formula, know your length formula. Square each component, add them up, take the square root. Now the distance formula, again, not as likely to show up on the exam. If they test you on this, they would have tested it on the test already, but just in case, because it is covered in this course, I want to go over it with you. Distance specifically, they're talking about the distance between 2 vectors. So for example, if I have 2 vectors like this, what they're asking for is the distance between the 2 tips of these vectors, okay? That's the graphical meaning, but don't worry too much about it. They won't make you graph anything. But that's what they're talking about when they're asking for distance between the 2 vectors. It has a formula. It looks very similar to the length formula. It's a bunch of things squared added together. Oops, sorry, that should be a squared. Please change that for me. It's a bunch of things squared added together, and then you're taking the square root. But first, what you got to do is you need to subtract the 2 components. So since you have 2 vectors, u and v, you're going to take u minus v, each of the components, subtract them. Then square those results, add them up, and then take the square root. Okay, so let's take a look at this example here. U is in R4, V is in R4. We can only find distance between the 2 if they're both in the same space like this. Then to find the distance U and V, that's going to be the square root of each of the components. We subtract them and then we square. So I'm going to do 1 minus 2 squared plus the next number, 0 minus 1 squared plus the next numbers, negative 2 minus 1 squared plus the next number, 1 minus 4 squared. Just a little bit different than the length formula. You have to do an extra thing. You need to subtract. So let's do this. 1 minus 2 is negative 1 squared, plus 0 minus 1, again, negative 1 squared. Negative 2 minus 1 makes it more negative, negative 3 squared. 1 minus 4 is negative 3 squared. Okay. Now, square each one. Remember, it becomes positive when you square them. So negative 1 squared is 1, plus 1, and then negative 3 squared is 9, plus 9. 1 plus 9 is 10, and we're just doing this twice, so 10 plus 10 is 20. So this is the square root of 20. So on the exam, if they somehow ask for the distance between two vectors, then you would choose the answer square root of 20, okay? Again, I don't think it's likely, but just in case, know the formula. It's very similar to length. You just have to do a subtraction. Before I move on, I just want to see a show of hands. How many of you guys are comfortable with the vector operations we've done so far? So multiplication, addition, subtraction, length. How do we feel? Okay. Wow, majority of you. Awesome. Okay. Sorry, I know I'm doing a lot of like voting and stuff. It's because I'm trying to get to know you guys, trying to see, you know, what works for you guys. I want to check on my speed here. How many of you guys think I'm going too fast? All right. How many of you guys think I'm going too slow? Okay, and everyone else, I'm assuming, thinks that it's okay. So majority of you think this is a good speed. Few of you think I can go a little bit slower, so I'll try to adjust it accordingly, okay? All right. When we talk about length, there's an application of length that comes out of it, and that's the unit vector. Unit vector is definitely tested on the test, on test 1. Sometimes they also like to test it on the final exam. Not a guarantee, but I have seen it on the final exam. They ask for unit vector questions. So what is a unit vector? The main thing to know for a unit vector is that the length is 1, okay? So unit vector, length 1, that's it. So they can spin this question however they want. They can say, hey, find the value of k so that this is a unit vector or something along those lines. If that's the case, then what you're doing is making sure that the length is 1. Now, the two applications that they'll usually ask if they do on the final exam would be asking for the unit vector that is in the same direction as v, or asking for the unit vector that is in the opposite direction of v. And there's a little formula that I need you to memorize for me. If they're asking for the unit vector in the same direction as v, what you're going to do is take the vector v divided by its length. If they want the opposite direction, then you take the vector v divided by its length, but then stick a negative in front because opposite means negative multiple, right? So v divided by its length gives you the unit vector, put a negative in front, gives you the unit vector in the opposite direction. And before we look at an example involving this, you also need to know something called special unit vectors. In R3, the special unit vectors are 1, 0, 0, 0, 1, 0, 0, 0, 1, your I, J, K. In R2, that's just 1, 0, which is I, and J is 0, 1, okay? So the special unit vectors exist in R2, R3, R4, and so on. It just means that one of the components is a 1, the rest are 0. So let's take a look at this example here. We want to find the unit vector in the same direction as 2i plus 4j minus 4k, and then we want to find the unit vector in the opposite direction as 2i plus 4j minus 4k. First, what is 2i plus 4j minus 4k? Well, that's 2 times I, which is 1, 0, 0, plus 4 times j, which is 0, 1, 0, minus 4 times k, which is 0, 0, 1. So you could write that out, 2 times 1, 0, 0, and then actually do the multiplication, add it up. But when you see I, J, K, as long as they're in alphabetical order like this, I, J, and K, you can just directly make them into a vector by taking the first number, by taking the number in front of the letter, okay? So that's 2 is the first letter, first number, and then positive 4 is the second number, and then negative 4, don't forget about that negative, is your third number. Anytime you have a negative, it comes with the number that comes after it. So that's the vector. So now we can use our formula. We want the unit vector in the same direction. I want you guys to try this out, okay? So remember, you're looking for v divided by the length of v. So our vector divided by the length of the vector. So give this a try. Use your length formula. Again, I'll give you guys a minute. And then when you're ready, we can take this up. All right, guys, let's take this up. If you're not all the way through, that's okay. Let's see how far you've gotten, okay? So our vector, v, is 2, 4, -4, divided by the length of v. The length has to do with the formula, the square root of each of the numbers squared added together, right? So this is going to be 2 squared plus 4 squared plus the -4 squared. So this is 2, 4, -4 stays on top. Then we have the square root of, let's calculate this, 2 times 2 is 4, 4 times 4 is 16, -4 times -4 is also 16. So this is 2, 4, -4. Then I have the square root of 4 plus 16, that's what, 20? And then add another 16, that's 36. Oh, that's a nice number. You need to know your perfect squares, like your 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, up to 10 square, okay? Know those ones. They expect you to know it without a calculator. So we know that 36 is actually 6 squared, 6 times 6. So the square root of 36 is going to be 6. So this is 2, 4, -4 divided by 6. That is the unit vector that's in the same direction as 2, 4, -4. Now, on the exam, if they do put a question like this, they will likely simplify. Okay. So they will likely simplify this. So you can rewrite this as take each of the numbers and divide by 6. So 2 over 6, 4 over 6, and -4 over 6. So they will write it like that. And if you look at each pair of numbers, we can reduce it further, right? Because each one is an even number. Each one's a multiple of 2. So we can simplify by dividing each one by 2. So we get 1 over 3, 2 over 3, -2 over 3. So that would be the vector that they want on the multiple choice answer options that is in the same direction as v. How about the second part when they ask for the one that is in the opposite direction of the same vector? Well, we can use that formula, -v over the length of v, but don't do all that work since we already found v over the length of v, okay? So this one here, we know it's in the same direction. So if I want the one that is in the opposite direction, so opposite direction, all I need to do is put a negative in front, right? Because the formula just changes by a negative. So it's going to be negative of 1/3, 2/3, -2/3, which again, they'll simplify. They'll bring the negative into the bracket because technically you're just multiplying everything by -1. So they'll make this -1/3, -2/3, and +2/3. Okay? That will be the unit vector in the opposite direction as your vector. Any questions? Alrighty, moving on then. We have a dot product. So we talked about how to multiply a number with a vector. We talked about how to add and subtract vectors, find the length of vectors. Now we're going to be talking about how to multiply vectors. And there's 2 ways to multiply a vector. There's your dot product and there's your cross product. They do different things and they're very, very different, okay? The dot product between u and v is written like this, u dot v, literally just a dot. What you're going to do is you're going to multiply the first pair of numbers together, the second pair of numbers, the third pair of numbers, all the way to the end, and then add them all up. So you're multiplying the components and then adding them up. So since you're adding up a bunch of numbers, the dot product results in a scalar, meaning a number. And this only works if the vectors have the same number of components. So they're either both in R2, both in R3, both in R4, and so on. So on the final exam, they can have questions like that, and you'll see it, I think, in the 2018 exam that I gave you, where they'll ask you which one of these is defined, or which one of these results in a scalar or a vector. Remember, when you take the dot product, it results in a scalar, in a number, okay? So we're going to practice dot product in just a second, but I want to go through some properties of dot product. Dot product can be used to find the angle between two vectors. Okay, this was tested on the test 1, but they could put it on the exam as well. I've seen it. So the formula for this is that u dot v, which again, remember, it's just a number, right? It's going to be the length of u times the length of v, which is numbers, times cosine of the angle in between. Now, this course is not calculus. They're not going to test you on your trig. You don't need to know how to evaluate cosine or sine or tan and nothing like that. They're just going to ask for, hey, what is cosine of the angle? Meaning, what is this number here? Okay. So let's actually go into an example. I'm going to come back and talk about these 5 properties later on. We're going to come back to this, but I want to do an example since we have this formula for angles fresh in our minds. So we want to find the cosine of the angle between these two vectors. Apply the formula, okay? So we have on the left side u dot v. So that's 1, -1, 1. Oops. Dot product with v, so that's 2, 0, -3. And that equals to the length of u. Sorry, I'm actually going to put, since we have u, I'm just going to put the u in there, times the length of v times cosine of theta. So pretend cosine of theta is like a variable x. You're trying to solve for x, okay? So why don't I give you guys again a minute, try this one out, okay? Do the dot product. Remember, you're multiplying each of the numbers together, adding them up, find the lengths, and then solve for this variable cosine theta. But I'm going to start taking it up now. See how far you got. So on the left-hand side, we're finding the dot product. You're multiplying each pair of numbers together, right? So 1 times 2, that's going to be a 2, plus -1 times 0. Zeros are your best friend. Anything times 0 is 0. Plus 1 times -3, which is -3. So that's your dot product on the left-hand side. Then we have to use our formulas for lengths. We have the square root of 1 squared plus -1 squared plus 1 squared. And then the length for 2, 0, -3, same thing. Square root of 2 squared plus 0 squared plus -3 squared, right? And then of course, cos theta. Don't break it up, just leave it as cos theta. Now it's number crunching time. So 2 plus 0 is 2, minus 3 is -1. And then here under the square root, 1 squared, that's 1 times 1, -1 times 1, and then 1 times 1. Second square root, 2 times 2 is 4, and then a 0, and -3 times -3, make sure you get that positive, right? Almost there, guys. We have -1 equals the square root, 1 plus 1 plus 1 is 3, and then 4 plus 9 is 13. So a lot of students that I've worked with can get it up to here because they're just applying the formulas, but then they don't know what to do from here. Cos theta, again, pretend this is like an x, okay? So if you want to get x by itself, you need to get rid of all the numbers in front, meaning we need to divide both sides by square root of 3 and square root of 13. So we have -1 over square root of 3, square root of 13 is cosine of theta, and that's your answer. You don't have to actually figure this out because you're not given a calculator, right? You can't use your calculator to calculate what the angle theta is. You're just going to leave it like this. Or if you don't see this answer in the multiple choice section, it could be because they simplified these square roots. Again, I don't think they'll do that. Like based on past exams, I've seen them leave it like this, but depending on your prof, they might combine the two square roots. So they might do -1 over one big square root, and they'll do 3 times 13, which is 39. Okay, so they might do that instead, but don't simplify it yet. Check your answers, see if it's there. If it's there, you're done. You don't have to worry about it. But if it's not there, then you have to try to simplify. Okay? So that's cosine of an angle. Now let's quickly talk about some properties. Some really important properties of dot product. First of all, dot product, essentially you're just multiplying two numbers together, right? So the order doesn't matter. If you do u dot v and v dot u, you get the same thing. So for example, in our question here, we did u dot v and we got -1 when we calculated it. If you did v dot u, switch the order, you'll still get -1, okay? U dot 0 is going to be 0, okay? Because if you're dot producting it with the 0 vector, you're multiplying each number by 0. Adding up a bunch of zeros is just 0. And then we have some bracket properties. So if you have v dot u plus v, so essentially what you want to do is you want to add up the two vectors and then find the dot product. You could actually find the dot product first. You kind of distribute this into your bracket just like you do in high school, right? When you multiply something into a bracket. So you do v dot u and then v dot w, and then you add those results. You can do that as well. And then finally, if you have a number times a dot product, that number can flow through a dot product, okay? I want you to write that down. Write it down right now. Numbers can flow through dot products. Because what's going to happen is on the final exam, they could ask you some property questions. Instead of memorizing all the different properties, because it's hard to memorize and hard to apply them, just know that numbers can flow through the dot product. Meaning if you have, for example, 3 times u dot v, this number can go in wherever it wants. So you can do 3u dot v, or you can do u dot 3v. So this number can flow throughout, where it can go wherever it wants in this dot product, okay? Guess what? It's the same for cross products, but we're going to see that later on. And then we have one more property that's important for you to remember, and that is the length of u squared is actually the dot product with itself. So u dot u is the same as if you found the length of u squared. Okay. Alrighty. So some properties just to know, we're going to see that in a second. Once I'm done teaching you all of chapter 1 stuff, we're going to do a bunch of questions together, and it's going to involve some of those properties. But dot product, why are we doing dot product? Well, first of all, we can find the angle, cosine of the angle between two vectors. But another very, very huge application is to do with orthogonal or perpendicular vectors. Another way to say that is a normal vector, which remember chapter 2, when you're talking about lines and planes, normal comes up a lot, right? So in this course on the final exam, if you see the word orthogonal, perpendicular, or normal, they all mean the same thing. Most likely you're going to see the words orthogonal and normal. That's what they like to use for the final exam questions usually. They'll call it orthogonal or normal. That just means that they're perpendicular, a 90-degree angle, okay? So what do we know about orthogonal vectors? Well, if u and v are orthogonal, if and only if the dot product is 0. That means that if the question tells you u and v are orthogonal, dot product's going to be 0. Or if they tell you, hey, the dot product is 0, then you know that they are orthogonal, okay? So one of the biggest applications we'll see later on as well is to check if two vectors are orthogonal. You check to see if the dot product is 0. But I want to talk about one extra application, and that is specifically in R2, only in R2. This does not exist in R3. If you were given a vector AB and you're asked to find a vector that is orthogonal, it's perpendicular to it, you're going to use this rule called the switch and flip. You're going to switch the two numbers and you're going to flip the sign of one of them. So for example, in number 8 here, question 8, find the vector that is orthogonal to -2, -5, we're going to switch, meaning we're going to end up with -5, -2, and then we got to flip one of the signs. So usually they're going to flip the sign so that the first number is positive. So we're going to flip this sign here and we're going to get +5, -2. So we know that this vector is going to be orthogonal to -2, -5. These are perpendicular. You can check it, find the dot product between the two and you'll get 0. I'll leave that for you to try, okay? Or if you really wanted to, you could have flipped the other number. So you could have left the -5 and flipped the -2 to make it +2. So that is another possible answer. That is orthogonal to -2, -5. We're going to need this later on in chapter 2 when we're doing lines. Only in R2 do we have this cool little trick. All right. Okay, we're going to move on to cross products now, which is the second type of multiplication. So we can multiply two vectors together using dot product. It's more straightforward. You multiply the numbers, add them up. And dot product helps you check if two vectors are orthogonal. Cross product, much more complicated looking, right? You have this formula here. Don't memorize this formula. I'm going to show you another way. And cross product, what it's going to do is it's going to produce a vector in R3. So you can only find the cross product between two vectors in R3. If it's R2, R4, there's no such thing as cross product. But if it's in R3, you can find the cross product. And this will produce a third vector that is orthogonal to the original two. So remember, dot product checks if two vectors are perpendicular. Cross product finds a vector that is perpendicular. Okay, I'm going to write that down for you because I know a lot of students mix it up. They don't know when to use which one. So dot product checks if two vectors are orthogonal, meaning perpendicular, and the cross product finds a vector that is orthogonal to the other two. So one's used for checking, one's used for finding. Write that down for me, please. Okay, so again, I'm going to leave these properties for now. We're going to come back to it, but I want to do question 9 first. So question 9, we want to find an orthogonal vector to both u and v. So we're trying to find a vector that's perpendicular to these two. If you're finding an orthogonal vector, that is cross product. Okay, so we need to take the cross product between these two. Now, I'm not going to use that formula. It's too long, hard to memorize. I know some of you guys are already really good at cross products. If you are, ignore me, find the cross product on your own, do it, okay? But I'm going to show you how I find cross products. I use something called the shoelace method. So you take the first vector, u, and you write it out twice. So 1, -2, 0, 1, -2, 0. Then you do the same thing with v next to it. So I have v, which is -1, 0, 5, -1, 0, 5. Make sure your numbers line up. And then now you're going to tie your shoelaces, okay? So we're going to cross off the first and the last. It's kind of like in your shoelace, and then there's X's in between, right? Now we're going to tie them. So u cross v is going to equal the first component, the first number, is going to be our -2 times 5 minus 0 times 0. So that's our first pair of lacing, right? Crisscross, like tying your shoelace. And then the second number, do the same thing. 0 times -1 minus 1 times 5. Okay. Just give me one sec here. I'm writing a little too big. Need a little more space. Okay. And then the third number, same thing. 1 times 0 minus -2 times -1. And that's it. That is your cross product. You have to simplify it, but that's going to give you your vector. And it looks like a shoelace. So here we have negative 2 times 5, which is negative 10, minus 0. And then 0 times negative 1 is 0, minus 5. 1 times 0 is 0, minus, be careful with your negatives, negative 2 times negative 1 is positive 2. Okay. And then keep going. So negative 10 minus 0 is negative 10. 0 minus 5 is negative 5, and 0 minus 2 is negative 2. So this vector is orthogonal to both u and v. You can check that. I'm going to leave it as an exercise. But if you find the dot product between u and this vector, and the dot product between v and this vector, you will get 0. Okay? So that's our cross product there. Now let's quickly talk about the properties. Let's go back and talk properties here. U cross V. Now, because the pattern is more intricate, we're doing this shoelace thing and there's subtraction involved, the cross product, the order does matter. So if I did U cross V, that's not the same as V cross U. It's actually the negative of V cross U. So for example, in number 9 here, when I did U cross V, I got negative 10, negative 5, negative 2. If I did V cross U the other way, I would actually get positive 10, positive 5, positive 2. It's going to be the opposite, the negative of this vector. Okay. This next one, if you have a number C, a constant C, and a cross product, guess what? Numbers flow through cross products. Just like dot products, right? Numbers can flow through a cross product, just like it flows through a dot product. Okay. Next two properties involve brackets. It's the same as with high school math. If you have something and you're multiplying it by a bracket, you can multiply it in. So U cross V, U cross W, you can multiply it in. Same with if you have it at the end here, you'll do U cross W and then V cross W. What if you're cross producting it with a 0 vector? So in that case, you're going to end up with a 0 vector. Be very careful with this. The vector u dot product with the 0 vector gives you the number 0, but the vector u cross product with the vector 0 gives you the vector 0. So one gives you a number 0, one gives you a vector 0. Okay. And then this last property I included here because they talk about it in the textbook a little bit, but most profs don't include it, and I've never seen this property on the exam. So I would actually not even bother memorizing it. I've never seen it on the exam. Unless for some reason your prof in your section talked about it a lot, then hey, you should know it. All right. Okay, the last thing we got to talk about in this section is applications of cross product. There are 3 applications, and it has to do with shapes. You have the area of a parallelogram, the area of a triangle, and then the volume of a parallelepiped. So I have the 3 diagrams here. Parallelogram has 4 corners, right? 4 vertices. If they're being nice to you on the final exam and they ask for the area of a parallelogram defined by u and v, great. You're going to take the cross product and then find the length of the cross product. Remember, these double lines mean the length. But if they're trying to be a little trickier, they're trying to be a little meaner to you, what they're going to do is they're going to give you the vertices. So they can give you this corner A, this corner B, this corner C, and this corner D, which are points. How do we turn points into vectors? Think, think, think. We talked about this. The only way to turn points into vectors, what do? We do a Backward subtraction, right? Remember, the vector PQ is Q minus P. So in this case, the vector V is going to be B minus A, and the vector U is going to be D minus A. So if they're trying to trick you a little bit on the final exam, instead of giving you the vectors U and V, they can give you the corners. Take those points, do the subtraction, B minus A, D minus A, to get your V and U. Okay? Now for the area of a triangle, it's very similar. Again, if they are nice and they give you these vectors, U and V, take the cross product and then find the length of that cross product. And then you have to divide it in half, divide it by 2, because look at this. Half of a parallelogram is a triangle. That's why we divide it in half, multiply by 1/2. But if they're being mean and they don't give you U and V, that's okay. They can give you these corner points, A, B, and C. Then again, we know that V is just B minus A, and we know that U is C minus A. All right? And then you can find the cross product, the length, and then divide it in half. So those are formulas that you have to memorize. Last but not least, volume of a parallelepiped. I have seen this one show up on the final exam. I think this one showed up on your test as well. Volume of a parallelepiped. This one, they're not going to give you corner points. It's going to be straightforward. They won't try to trick you. They're going to give you U, V, and W, the length, the width, and the height of this parallelogram. Or this parallelepiped, I should say. What you're going to do is you're going to take the cross product between two vectors, then the dot product, and then the absolute values. Absolute value. Not the length, because once you find the cross product and then the dot product, you're going to get a number. Then you want to find the absolute value of that number, meaning make sure it's positive because volume has to be positive. Okay? Let's take a look at our example here, shall we? We want to find the volume of the parallelepiped defined by U, V, and W. So we use our formula, right? The volume is the absolute value of U dot V cross W. Now, the thing is, this order doesn't matter. So my tip for you for the final exam to make sure you avoid mistakes as much as possible, pick the two nicest vector and find the dot product. Nicest vector, I mean the ones with zeros. Zeros is the easiest to calculate. So if you look at U, it has a 0, V has a 0, W doesn't have zeros. So guess what? I'm actually going to find the cross product between U and V, because it's going to be a lot nicer when we're finding the cross product with things that have a lot of zeros in them. Then I'm going to take the dot product with W. Okay? So why don't I give you guys a minute? I want you to calculate this. So you want to find the cross product using whatever method you want. I use the shoelace method, okay? Find the cross product and then the dot product. I'm going to mute my mic. I'm going to write out the cross product on the screen. I want you to do it on your own, but if you're stuck, you can check with me. All right, let's take this up. If you take the cross product, you should end up with 2, 0, negative 2. How many of you guys got that for your cross product? 2, 0, negative 2. Awesome, a lot of you guys did. Okay, if you didn't, let me know, okay? Let me know in the chat, Q&A, so I can help you out. Or double check this, maybe it's just like a negative sign somewhere that was different, okay? And once you have that cross product, we want to find the dot product with our last vector. So 3, negative 1, 1, dot product with 2, 0, negative 2. And then you multiply each of those sets of numbers together, add them up. We ended up with positive 4. So since it's already positive, we can just drop those sticks and then it's just 4. If it was negative 4, then it would still be positive 4 as our answer because the volume always has to be a positive volume, okay? That's pretty much a wrap on chapter 1. We have a lot of questions still we have to do just to make sure you're used to the exam-like questions. If there's any questions about dot or cross product, let me know. All right, let's dive into exam-like questions. We'll do a couple of these, then we'll go on our break. We're almost at our first break, okay? You can do this, guys. So which one of the following is not a unit vector? Remember, unit vector means length 1. So you're trying to find which one of these does not have a length of 1. I'm going to open up the poll. I want you guys to vote. I want to see how you guys feel about this. So give this one a try, find the length, see which one is not 1, and then when you're ready, you can vote. Thank you everyone for voting. We have two competing answers here. Some people are saying that it's C, some people are saying that it's E. Let's check together, okay? Let's see what we get here. Remember, to find the length, we need to square each number and then add them up. So in A, we're going to get 0 squared plus -1 squared, and then the square root of that, right? So that's going to be the square root of 0 plus 1. Square root of 1 is 1. So this one does have length of 1. So it can't be answer A. Let's do B. We have the square root of, okay, we're going to take the square of each number. So square root of 1/2 squared plus square root of 1/2 squared. How do squares and square roots work? They're enemies, right? They cross each other off. So the square of a square root actually cancels. The square of a square root actually cancels. So this is the square root of 1/2 plus 1/2, which is square root of 1. Again, that's 1. So B actually has a length of 1. It's not that one. Now, I know why some of you guys chose C, because C has this negative, and negative makes it seem kind of like, am I subtracting? But remember, when you take the square of something, can you ever have a negative? Something squared is always positive, because 2 positive numbers multiplied together gives you positive, 2 negative numbers gives you positive. So this is the square root of 1/2 squared plus negative square root of 1/2 squared. So the square and the square roots, they cancel, and the negative square turns into a positive. So this is actually the same thing as B. We get 1/2 plus 1/2, which is the square root of 1. That's also 1, so it can't be answer C. So now we're down to D and E. Let's see what we got here. D, okay, we have the square root of each of the numbers squared. So 1/4 squared plus 3/4 squared. How do we square a fraction? Yes, thank you. Thank you. You helped me out there. To square a fraction, you square the numerator, square the denominator. So the 1/4 squared is going to be 1 squared, which is 1, over 4 squared, which is 16. You can also think of it as 1/4 times 1/4. You multiply the tops, multiply the bottoms, okay? Then the second number, again, multiply the tops, so 3 squared, 3 times 3 is 9, over 4 squared, 4 times 4 is 16. Oh, now that they have the same common denominator, we can just add the tops together. 1 plus 9 is 10. That's 10 over 16. Does that equal 1? No, right? That is not 1. So actually our answer is D. Very few of you guys chose D, and I think it's because these fractions make it a little trickier, right? If they were to put a question like this on the final exam about unit vectors, likely they're going to throw in some fractions just to make sure you know what you're doing, okay? It's not going to be as nice numbers. But let's just check E just to see that the length does equal 1 for E. We take the square root of each of the numbers squared, so -3/5 squared plus -4/5 squared. So this is the square root, okay? First of all, the negative squared, they turn positive, right? Negative times negative is positive. Now we square each of the top and bottom. So 3 squared, that's 9. 5 squared is 25. 4 squared, 4 times 4 is 16. 5 times 5 is 25. So you see how for this one, when you add them up, you do get 25 over 25, which is 1. So this actually does equal 1. So answer E is also not correct. All right. I know it's a trickier one with all these fractions. All right, so number 2. We were on the chapter 1 questions. Given that u and v are vectors in R3, so we know they're R3, which of the following are always true? These questions, I know a lot of students get stumped on it because they involve like these properties and whatnot. So let's go ahead and try to review these. So number one, we have a dot product. Remember what we know about dot product. The order doesn't matter, right? So u dot v should be the same as v dot u. Also, there's this negative involved. A negative is like just a number, right? A number -1. Numbers can flow through a dot product, remember that. So technically on the left-hand side here, this is just a negative u dot v. So I can kind of flow the negative sign to the front. Same thing over here. This is negative v dot u. And remember, u dot v and v dot u are the same, right? Meaning that this one has to be true. So I know I can cross off some answers already. D can't be true because 1 has to be true. E can't be true because it doesn't include 1. Okay. Now let's take a look at number 2. The length of u plus v is the length of u plus the length of v. Is that true? Well, think about your formulas, right? This is the square root of u plus v, each of the numbers squared, added together. Whereas this is the square root of the numbers in u squared added together, plus the square root of the numbers in v squared added together. So how would I know if this is true or not? Well, come up with an example. If we're not sure, because this isn't one of our properties that we had listed, if it's not one of those direct properties, guess what? We're going to try an example. So for number 2, let's come up with an example for this. So pick nice numbers. Don't pick something like -0.5, like that's disgusting. Just pick some nice numbers, like for example, u, I'm going to say it's 1, 0, 0 maybe. And then v, I'm going to say it's 1, 1, 0. Or even nicer, let's just make it 0, 1, 0. Okay. Let's test it out. On the left side of the equation, we had the length of u plus v. So let's calculate that. That's going to be the length of u plus v, that's 1, 1, 0. And that's going to be the square root of 1 squared plus 1 squared plus 0 squared. So that's the square root of 2, right? And then the right side, that's going to be the length of u plus the length of v. And the length of u is the square root of 1 squared plus 0 squared plus 0 squared. Length of v, square root of 0 squared plus 1 squared plus 0 squared. And if you calculate this one, this is the square root of 1 plus the square root of 1, which is 2. These are not the same, right? Square root of 2 and 2 are not the same. So here's the thing. If you're trying to prove if a statement is true, as long as you come up with one false example, one counter example, you're done. That can't be true. But if, let's say you came up with some numbers and just so happened, yes, left side equals right side, then you have to test a few more just to make sure that it's always true. Okay, but for this one, we just tested it out. We found a counter example, so it's not true. So it can't be A. So now we're down to a 50-50 shot. You see how we don't even need to look at number 3, we just need to look at number 4, because in the answer, it's either 1 and 4 or just 1. So let's take a look at number 4. Remember when you have dot product or cross product with 0, something really nice happens. These were the properties I asked you to memorize. 0 dot anything. You're just doing 0 times something plus 0 times something plus 0 times something. So this is going to be the number 0. And the cross product, if you have a 0 vector cross a 0 vector, remember, or sorry, cross a vector v. When you're taking the cross product, you're going to end up with a vector. So the vector 0. So essentially what you have is you have 0 times the vector 0, 0, 0. So you're going to get the vector 0, 0, 0. So this is the 0 vector, not the 0 number. Be very careful with that. So this one's actually not true either. So the only correct answer is C. So you're using all those properties that we learned, but then applying it to slightly different statements like these. Any questions about this one? I know this one can be a little tricky, especially number 4. Always remember what you're doing. Are you do you have a number or do you have a vector? Okay, always ask yourself that when it comes to zeros. All right. Okay, moving on to number 3. We want to find the value of C. So one of these solve for C, solve for K stuff, we know we're going to set up some kind of equation such that U and V are orthogonal. When it comes to orthogonal, there's 2 things. Either we check it with the dot product equals 0, or we find the cross product to find the actual orthogonal vector. I'm not asked to find another vector, right? I'm asked to find C so that these are orthogonal. So I need to check that they are orthogonal. Okay, so check that UV are orthogonal. So when I'm checking if they're orthogonal, I'm using the dot product. Okay, so that means I want U dot V to be 0. That's how they're orthogonal. Use this, do the dot product, and actually solve for C. I'm going to open up the poll. I want you to tell me what you think C should be. Thanks for voting, guys. The correct answer for this one, drum roll, okay, is C, okay? It should be -2. Let's just double check just to make sure we're all on the same page. Remember, when you're doing dot product, you're doing the 1 times -2 plus the -5 times C, so that's -5C, plus the 2 times -4, and we want that to equal 0. So we have this equation. So this is -2 minus 5C minus 8 gives us 0. Let's group the like terms. -2, -8 gives us a very negative number, -10, minus 5C is 0. Then we have to solve this equation. So solving the equation, we got to move stuff around. First, don't touch the -5 because that's too close to C. Let's get rid of the -10. So I'm going to add 10 to both sides so that we move it to the other side. So we have -5C equals 10, and then we divide by the -5. So you got to deal with your addition subtractions before you deal with the multiplication divisions. So C is going to be -2. So that's how we got that answer. All right. So if you got it, great, give yourself a pat on the back. If not, double check your algebra here. Copy this down. And if you're stuck on any of these steps, let me know. I can help you. All right. Number 4, let's do this one together, shall we? We want to find the value of C such that U and V are parallel. They're collinear. So very similar to a 2018 question, actually. So if they're parallel or collinear, again, you're trying to solve for C. Remember, parallel, collinear, opposite. What you're doing is you're taking each pair of numbers and dividing them. So 1 divided by -2, so 1 over -2, has to equal -5 divided by C, which has to equal 2 divided by -4. Because they're parallel, collinear, meaning they have to be scalar multiples. So I need to be able to go from one number to the other by multiplying by the same number, okay? So if you look at this, well, this is -1/2. This number here is also -1/2. So that makes sense. They should equal, meaning to get from U to V, okay, U is -1/2 of V. So I need to multiply by -2 to get from U to V, okay? So I have this equation now that I can use. -1/2 equals -5/C. Again, I don't like fractions, right? So you want to get rid of them by multiplying by the denominator. I have a little trick to show you. When you have a fraction equals a fraction on the final exam, you want to use something called cross multiplying. That will get rid of all your fractions. So we're going to crisscross multiply. So I'm going to multiply the C up and multiply the 2 up. So that means that we have -1 times C is going to equal -5 times 2. Crisscross, cross multiplying on the exam will get rid of your fractions. So this is -C equals -10. Oh, dividing by -1 on both sides. C is going to be +10. All right, so we see that C or K or whatever value they want is going to be 10 so that you have these two vectors being parallel. Parallel, opposite, orthogonal. These are all good questions they can put on the final. By the way, your final exam, based on all the past exams that I looked at, I know this year they announced it's going to be 50 marks in total. In the past, it was similar. So it's going to be give or take 35 multiple choice questions. They don't try to trick you with the multiple choice in terms of ordering, meaning that you're going to see the vector stuff at the beginning of the multiple choice section, then lines and planes, then systems of linear equations, matrices, determinants. It's going to be relatively in the same order in the multiple choice. When it comes to the short answer, that they can scramble in around, okay? All right, moving on, question 5. Similar to a question on 2018 as well. Again, notice that it's earlier on in the multiple choice. Usually these questions will be earlier on. So you are given U, which is in, what is that, R5. There's 5 numbers in there, R5. V, again, R5, because there's 5 numbers. And W is R5, because there's 5 numbers. We want to find U dot V dot W if possible. Now, when they ask you to do multiple things like a dot product and a cross product or dot product, more than just one single dot product or one single cross product, always check if it's possible first. Okay, that's how they try to see if you know what you're doing. So if you find the dot product U dot V, are you going to get a number or are you going to get a vector? I want to see a vote from you guys. Who thinks that U dot V is going to be a number? Raise your hand. Okay. Who thinks that U dot V is going to be a vector? Raise your hand. Okay. And then everyone else kind of on the fence, right, in between. Majority of people said number, and number is correct. So if you said number, great. If you said vector, that's okay. That's why we're doing this review, right? U dot V, anytime you do a dot product, that's going to give you a number, okay? So if you don't remember that, here's your review. Dot product gives you a number. Cross product gives you a vector, specifically in R3, okay? So dot, number, cross, vector. So this is going to give you a number. Now my question is, can we find a number dot product with a vector? Not multiplying, dot product. No, right? Dot product only works between 2 vectors because you have to take each of the numbers, multiply them together, and then add them up. But if I have a number, dot product, a vector, I can't do that. So this operation is actually not defined because we can't do a number, dot product, a vector. That's not allowed. You can only do vector, dot, vector. We can do a number times a vector, but not a number dot product a vector, okay? So that's why this operation is not defined. In 2018, when they put this question on the exam, a lot of students actually tried to do it and they spent a lot of time on it. But instead, look at the question first, see if it's defined before you actually go ahead and do the calculations, all right? So hopefully this gives you a taste of the types of questions that they will give you on the exam. Okay. Number 6, which of the following vectors is not parallel to the line passing through the points 1, 2, and -3, 4? So you might be thinking, Jess, we haven't reviewed lines yet. Lines is in the next chapter. But we don't need to know lines yet, actually. Because when I have 2 points, how do I turn points into vectors? There's only one way. I can turn points into vectors by backwards subtraction, right? Remember, PQ is Q minus P. So really all I have to do is subtract this and then see which of these vectors is not parallel to that vector, okay? So let's start this one together at least. So the vector that we're looking for that passes through these 2 points is going to be -3, 4 minus 1, 2. Let's subtract. -3 minus 1 is -4. 4 minus 2 is 2. So we're looking for which of these vectors is not parallel to this guy. Okay. So a couple ways to do this. When it comes to parallel, we can do our trick, right? You can do, okay, the first number divided by the first number has to equal this number divided by this number. But since we're not solving for k or solving for c here, we can actually just look at the relationship with the vector itself because we know both numbers. It means that to get from the second number to the first number, I need to multiply by -2. So you're looking for which vector cannot do this. So let's take a look at A. For A, if I take my second number and times it by -2, do I end up with 5? Well, negative times a negative is positive. 5 over 2 times 2, it's like 2 over 1. Yes, the 2's cancel, so this one is correct. -5 over 2 times -2 does give me 5. So this one is going to be parallel. Do the same for the other ones. Take the second number, multiply by -2, see if you end up with the first number. If you do, that means that they are parallel. Okay. So if you take the -3, multiply by -2, oh, that does give me 6, so this one's good. Take the 1, multiply by -2, oh, that does give me -2, so you're good. Take the -1/2, multiply by -2. Negative times negative is positive. What's 1/2 times 2? 1/2 times 2 should be a 1, not a 1 over 4. So this one, D, is not parallel to our line. Okay, so those are some of the ways that you can do this. Again, if you didn't like that method, go back to what we've been doing, which is take, okay, for A, you're going to take 5 divided by -4, see if that equals -5 over 2 divided by 2. For B, you're going to see a 6 divided by -4 equals -3 divided by 2, okay? So you can check each of those. The instant you come up with an equation that doesn't work, that's when they're not parallel. So you can go back to that if you want. I just think this way is a little bit faster. Okay? All right, doesn't seem like there's questions, so I'm going to move on until you stop me. All right, number 7. Find the unit vector in the opposite direction as v. I'll let you guys try this one. I'm going to release the poll here. Remember, just some hints for you. The formula is -v over the length of v. All right, that's how we find a unit vector in the opposite direction. So give that a try. When you're ready, you can vote. Maybe give you guys a minute and a half. Thank you. Majority of people said E. Good job. E is the correct answer here, okay? But let's just double check our math here. We have -v, 1, -1, 0, -1, 0, right? That's your v, divided by the length of v. So remember your length formula. It comes up over and over and over again. It's the square root of each of the numbers squared added together. So we have a 1 squared, -1 squared, 0 squared, -1 squared, and 0 squared. So this is -1, -1, 0, -1, 0, divided by the square root. You get 1 plus 1 plus 1, which is 3. So you can already see that your answer can't be A, B, or C, because there has to be that 1 over square root of 3. Now, if you simplify this, take each of the numbers, you're going to multiply by a negative, and then divide by square root of 3. So we get -1 over root 3, positive 1 over square root of 3, 0, positive 1 over square root of 3, and 0. So that's why the answer is E. All right. Good job, guys. If you didn't get it, hey, that's fine. That's why we're doing this review. But let me know if it's like the number part that got you or the formulas, so I can help you out. Question 8. I love these questions because a lot of students don't know where to start. So I like them because I have a way of doing them that I think helps. Okay. So we're given that u, v, and w are vectors in R3. Which of the following operations are defined? What I'm going to do is I'm going to use a number symbol if it's going to end up being a number, and a v that represents a vector. Okay, so let's take a look at number 1. I have u dot v in the numerator. Remember, dot product gives us a number, divided by the length of w. Is the length of w a number or a vector? Write that down on your page. Length is a number, right? Can we do a number divided by a number? Yes, a number divided by a number is a number. So yay, this one is defined. So 1 should be defined. So it can't be answer B. Now let's move on to 2. Do the brackets first. Okay, V cross W. Cross product, is that a number or a vector? Write it down. Cross product gives us a vector. And then we have the vector u, so that's a vector plus a vector. Can we add a vector and a vector if they're the same size? Or 3? Yeah, I can add a vector and a vector. I just add the numbers together, right? So this is a vector. Yay, it's defined. So I know both of these are defined so far. Now let's look at 3. Again, u is a vector, so let's just write it out, minus the length of a cross product. Is that going to be a vector or a number? Think about it. Cross product is a vector, right? So this is, I'm subtracting the length of a vector. The length of something is a number. So I have a vector minus a number. Can I do vector minus number? No. I can't do the vector minus the number 3. That's not allowed. So this one is not defined. So anything with a 3 in it can't be right, so meaning it can't be all of them. Number 4, u dot v dot product is a number or vector? Write it down. That's a number, right? So I have a number cross product with a vector. Can you cross a number and a vector? No, you can't. That's not allowed. That's not defined. So it can't be 4. So I can cross off E as well. So now I'm a 50-50 chance guessing between C and D. Let's check the last one, number 5. We have U cross V. Cross product is a vector. Dot product with W, which is a vector. Can we do vector dot vector? What do we get? We get a number. So this is allowed. This is defined. So my answer is 1, 2, and 5 are defined. So the answer is D. Okay, so use this trick on the exam if you see these defined possible questions, like if they ask you which of these are defined, which of these are possible, you know, use number to represent the result of a number, V to represent a vector, and then go all the way through. All right. Okay, moving on, because we have a lot still to cover. We want to find cosine theta where the angle theta is between these two vectors. So pretty much you want to use that cosine theta formula. Just to remind you what that looks like, it's u dot v equals the length of u, the length of v times cosine of the angle. Okay. So we first need the dot product. So that's 1, 1, 1, 0. Dot product, 0, 2, -1, -1. And that's going to equal the length of u times the length of v times cosine of the angle. And now apply your formulas, okay? Do that on your own. I'm going to write it out up here, but I want you to try it on your own, use the formulas, and you can check up here if you're stuck, all right? Okay, double check with my answers up here. When you do the dot product, you're multiplying each of these numbers together, and then you're adding them all up, right? If you do that, you should get a 1 on the left-hand side. And then on the right, you're using the length formula. So you're squaring each of your numbers, adding them together, and then finding the square root. So the length of u should be square root of 3. Length of v should be square root of 6. And then at the end, when you solve for cosine of theta, you just divide the 1 and the root 3, root 6. You don't have to do anything else. Don't do any trig stuff because you know you're not. It's not a calculus course. You don't need to know trig. Okay. Let me know if there's any questions about this one. It's very similar to a question we did earlier, but this time it's just in R4 instead of R3. Okay. Okay, moving on to number 10. Given that u and v are vectors in R3, both of these have 3 numbers, we want to compute u dot v times v cross u. So let's do them separately, okay? So let's do u dot v first. Dot products are usually easier. We're doing 1, 1, negative 1. Dot product was 0, negative 2, 2. Multiply the numbers. 1 times 0 is 0, plus 1 times negative 2 is negative 2, plus 1 times 2 is 2. Or sorry, negative 1 times 2, my bad, is negative 2. Sorry about that. So this gives me negative 2 plus negative 2, which is negative 4, okay? So that's the dot product. Now we need the cross product. The order matters when it comes to cross products. This is v cross u. So I'm going to write my v vector first. So it's 0, negative 2, 2, 0, negative 2, 2, and then the u, 1, 1, negative 1, 1, 1, negative 1. Shoelace time, okay? So we have negative 2 times negative 1. I'm going to do the multiplication as I go. Negative 2 times negative 1 is positive 2, minus, crisscross, 2 times 1 is 2. Then 2 times 1 is 2, minus 0 times negative 1 is 0. 0 times 1 is 0, minus negative 2 times 1 is negative 2. Okay, so you can either use a shoelace, or I know some of you guys do it sideways. There's a lot of different ways to do cross product, but your final answer should be 0, 2, and 2. Make sure you get that. Okay. So finally, we have to calculate u dot v, which is negative 4, times the v cross u, which is 0, 2, 2. So this is just a scalar multiplication, not a dot product, not a cross product. We're just taking this number and multiplying it into each number in the vector. So this is 0, negative 8, negative 8. That would be the answer you want for 10. All right, so that's the one that you would want to select on the final exam. And I guarantee you on the exam, they're going to have other options. They're going to have like the positive 0, 8, 8, something like that as well. Okay. Any questions? Okay, so moving on. Number 11. Number 11 slightly trickier. So given that u is negative 5 over 7v, and v dot u is negative 14, so the dot product is negative 14, we want to find the length of u. So you might be thinking, well, we know the length formula. Can we just use the length formula? But we don't know what u is. So since we don't know what u is, we can't find the length using length formula. Well, let's start with what we do know. We know that the dot product has to be negative 14, right? Well, if only I can change this v into some kind of u. How can we rewrite v in terms of u? Like if I want v to equal something something u, what can I do? Well, you can change this equation. You can rearrange this equation, right? So if you divide both sides by negative 5 over 7, you'll get v by itself. So you want u divided by negative 5 over 7. Dividing by a fraction, just some reminder, because they do expect you to know how to work with small fractions like this. Dividing by a fraction, we're going to flip and multiply. So the u stays the same, but now this is going to turn into a multiplication, and then we're going to flip the fraction. So it's going to be negative 7 over 5. Okay, quick reminder for fractions. So that means that v is going to be negative 7 over 5u. All right, now that we know what v is in terms of u, we can put it into this equation. So we know that v dot u, which is now negative 7 over 5u, right? You're just plugging this into the negative 7 over 5u, is, and then dot product with u is going to be negative 14. Well, still, how does that help us? At least now we have an equation that's just u, and we want to find the length of u. But how do we do that? Think back to your properties. I need you to dig for me. If you don't remember, go back to the previous page where the properties of dot product. How is the length of u related to the dot product? Remember this property? The length of u squared is u dot u. Remember that? So we do see a u dot u here. So that means that this is the length of u squared. So that means that negative 7 over 5 times the length of u squared is negative 14. And we want to solve for the length of u. So it's solving an equation now, okay? So to solve for this, let's divide by negative 7 over 5, divide by negative 7 over 5. So we see that the length of u squared is, again, dividing by a fraction, we flip and multiply. Let me just make all this smaller so I have space to write. Okay. All right. And then we can use this fraction trick. I want to introduce this to you just in case you do need some help with fractions. When you're multiplying two fractions, if there's a number on the top that divides with a number on the bottom, even if they're in different fractions, you can cancel them out. So for example, the 14 and the 7. 7 goes into 14 twice, 7 goes into 7 once. So you can do some simplifying so you don't have to multiply really big numbers. So this is the length of u squared is going to be negative times a negative is a positive. 2 times 5 is 10. 1 times 1 is 1, so I'm not going to write that. So that means that the length of u is square root of 10. This is a very hard question compared to all the other ones, right? It's very tricky. If they choose to put something like this on the exam, it'll be like one question. They're not going to try to give you like 10 very, very hard questions in a row because they need to keep their average a certain average, right? So a similar question like this, I've seen it on an older exam, so I wanted to bring it up to make sure you are exposed to it. Okay, this is a hard one. All right, number 12. I think this might be the last one in this section. We want to find the area of the triangle with these vertices. So I'm just going to sketch it out, P, Q, and R. It doesn't have to be exact. I'm just sketching it out so we see the triangle. Remember the formula for the area of a triangle. It's 1/2 times the length of whatever vector u and vector v are. So it's going to be u cross v. So my question is, how do we get u and v? How do we turn points into vectors? Write that down. I want you to find u and v for me. Okay, hopefully you were able to get u and v. U is PQ, so we're going to do Q minus P. Remember, we subtract backwards, right? And then V is PR, subtract backwards, R minus P. Okay? If you calculate this, U is going to give you a -2, -2, -1. V is going to be 4, -1, -2. So now we're going to put these into our formula. So this is 1/2 the length of u, which is -2, -2, -1, cross v, 4, -1, -2. Okay. Just for time's sake, I'm going to leave it as an exercise for you to find the cross product. Okay, so exercise, cross product, and then the length. The final answer, you should have 1/2 square root of 173. There's no point in seeing me like do the cross product. I want you guys to try this out. Write down this answer on your page right now. And then after the session, if you're very comfortable with cross products and lengths, just take it as it is. But if not, I want you to do it after the session or during break and see if you get this answer. All right. If not, let me know. And of course, in the full solutions, there's step-by-step solutions in there as well. Okay.